We are here with SQL Friday number 66, and our star today is Javier Villegas, I think it's pronounced.
Yes, pretty good.
Who is connecting from Argentina. I'm in the middle of Stockholm for the moment. The session is recorded, so just so you know, if you have your camera on, that might show on the recording. But for the rest of it, it's the normal routine for an online meeting, questions in the chat, and I will relay them. And if you're not me or Javier, then please mute your microphone. Welcome to SQL Friday, Javier.
Thank you. I think it's my second time. So yeah,
Yes.
yeah. I'm glad to be here. And Magnus, thank you for the invitation again. All right, so let's start the session today. Will be performance features in SQL Server and Azure feature. Definitely a topic that I found quite interesting, especially these days, right? Microsoft has announced the upcoming version of SQL Server, SQL Server 2022, with a lot of changes with in the space of performance. So it's good that we know the basis, we know what it is available today in SQL Server, in some version of SQL servers, as well as in Azure SQL. So we start getting ready for what's coming next. A little bit about myself. My name is Javier Villegas. I am from Buenos Aires, Argentina. I work as IT director in the database and BI services at Mediterranean Shipping Company for the last 16 years. I've been working with SQL Server and data platform for over 25 years. I am Microsoft MVP since 2016, and I'm also Microsoft certified trainer. I'm also part of the board of advisors for the Azure Data Tech community, and also a technical speaker. I love to participate in everywhere in where we can chat, discuss, and share something related to technology, especially SQL and databases, which is my passion. I'm also one of the leaders of the local user group, SQL Argentina, in where we have our meetups, our regular meetings, virtual for now, hopefully in person soon. And I'm also one of the organizers of a podcast that we run down here during pandemic. It was Azure en el Bar. So we sit down with friends, colleagues, professionals around the globe, just as if we are sitting on a real bar, just sharing our favorite beverage, just chatting. So we have a lot of fun. You also have my contact information, email address, Twitter, LinkedIn, my blog. So feel free to network with me, to contact me. I like to engage and have conversations. If you have questions about this presentation or any other thing that you would like to discuss, I love to engage. So let's define a little bit what we're going to be talking about, and in few words, what is Azure SQL and what is SQL Server, right? You know that a few years ago, Microsoft became with this new framework, or I like to call it umbrella, which is Azure SQL, which initially has one component, then 2, 3, and recently 4, right? The very first component that was several years ago when Azure was announced, right? Back then it was Windows Azure. It was Azure SQL Database, right? Then virtual machines running SQL Server. Few years back, manage instance, and recently they also added the fourth component, which is Azure SQL Edge, which give us the possibility of running an SQL Server-like engine on an ARM device like Raspberry Pi or a sensor or any kind of small device. So this is what is Azure SQL this day. The topic today is basically performance features. So we're going to try to cover the features that fit for all the components, right? Microsoft like to say that it's just SQL, right? So all the knowledge that we have, that we bring from the many years working with T-SQL, working with maintenance plan, with indexes, with whatever. It's not like we lose it and we have to start over. No, it's just SQL, so it's totally applicable in this new environment. In terms of SQL Server, where you know the history, there are a bunch of versions, right? But what I like to emphasize here is that Microsoft called the modern version of SQL Server the ones starting from SQL Server 2016. So the features that we will be focusing today, I will specify on which version we can find them, right? But all of them are starting from 2016, right? And this is because we're going to be focusing on the modern version of SQL Server, right? So excluding a little bit the Azure SQL Edge, we have these three main components, right? Azure virtual machines running SQL Server, the very same SQL Server that we run on-prem in our bare metal servers, in our VMware virtual machines, Hyper-V virtual machine running SQL Server. Well, that is exactly the same in Azure SQL VMs. The benefit is that when we deploy one of these virtual machines from the marketplace in Azure, there are multiple, let's say, best practices in terms of how to configure SQL Server, more specifically about the storage, right, that are already covered and applied on our deployment just because we deployed from the marketplace. That's something quite important. And in a matter of few minutes, we can have one of these VMs up and running. That is what Microsoft called infrastructure as a service, in where ourselves we have to take care of the infrastructure behind SQL Server, the infrastructure that is supporting SQL Server, like the patching, the backups, high availability, disaster recovery, and those things. They are doing some efforts in order to support some of the things that we had to do today and try to make an approach to something similar to what they are doing in the other bucket of the Azure SQL family, which is platform as a service, right? Over there, we have two components, Azure SQL Database, which is the one I said coming from the very first edition or version of Azure more than 10 years ago. Of course, it has changed and it's much better and different than what used to be. And a little bit more than 3 years ago, Microsoft introduced Azure SQL Managed Instance. The idea is that this is, since it's platform as a service, right? We don't have to take care of the infrastructure behind our SQL Server. So we don't care what is behind, but Microsoft assures us that we have high availability out of the box, just deploying one of these, right? We don't need to, let's say, create the cluster, the availability group, and all those things. Is part of, HA is part of the solution. Same for Azure SQL Database, right? So today, SQL Server is everywhere, right? We can see, as we said, SQL Server running in our data center, running on Windows Server, for example, with 2019. You know, since 2017, SQL also has the possibility of running at the top of the major Linux distributions, Red Hat, SUSE, Ubuntu. Same as for containers, like for example Dockers, and if we want to orchestrate those containers and generate environments which are, let's say, more production-like with high availability, disaster recovery, well, we can run those containers in Kubernetes. As we just said, virtual machines in Azure, managed instance, Azure SQL Database, and Azure SQL Edge, right? So this is SQL or Azure SQL almost everywhere. Quite different to how it was when I started working with SQL Server 25 years ago, when you only had the possibility of running SQL Server 6.0, 6.5 at the top of Windows Server, right? Now it's quite different. So another important thing or something to emphasize is that beside all the benefits that we talk about platform as a service, that we don't need to take care of the backups, we don't need to take care of high availability, disaster recovery, patching. There are few important things that I like to highlight, right? Everything in Azure SQL, you have this benefit of being able to scale very easily. If you have your VM, if you have a managed instance or an Azure SQL database, you can, in few clicks, scale up and scale down in terms of resources. You can, if you're running out of horsepower in your virtual machine, you can easily switch to another with more processors, with more memory, better and faster disk, etc. Just from the Azure portal, you can do it right away. Remember how it is or how it was on a data center when you had to scale up your server. I mean, definitely it's not a few clicks, right? You have to contact the vendor, you have to find out which is the right memory, the right CPU, buy then, find out the maintenance window to do the maintenance, etc. So at least few weeks, right? Here you can scale up and down all these Azure SQL services in a matter of few minutes. Something also quite interesting is this concept of versionless, right? SQL Server, historically, we have versions, right? And every time that Microsoft release a major version, we have to run a bunch of, let's say, validation from our application just to make sure that it works well with the new version. There are no major regressions, etc., etc. Well, in Azure SQL, meaning Azure SQL Database and Managed Instance, Microsoft call it Azure SQL versionless. So there are no versions, right? So you won't see Azure SQL version 1, 2, 3, whatever. No, it's always Azure SQL and that's it. And this is how it's going to continue, right? So this way, all these problems that we used to face, in theory, they're going to be covered because they guarantee that we should not have this problem anymore. Since it's versionless, does it mean that it's static and it's not going to change? Well, the answer is absolutely not. I would say the other way around. Microsoft is going with the innovation, with the new features to Azure SQL first, and then bringing those features to the SQL Server product, right? And when we start, and now we're going to start focusing on performance and the points on why we are here today. Remember, I said at some point it's just SQL. So all the focus that we used to have in our environment, right, hasn't changed. We always have to take care of three important pillars, right, in terms of performance, of course. CPU, memory, and I/O, right? That hasn't changed, and most probably it will never change, right? So over the course of this presentation, we will see which are the features on how we can, take care of these three components. Also, taking care of performance maintenance tasks, like, for example, index maintenance in terms of fragmentation, statistics, etc. And then there is this concept of intelligent performance, right, which was introduced back in SQL Server 2016. And the idea of this intelligent performance, which is actually not one feature, is a set of feature, is basically to tackle down this situation, this historic situation that we always or we see in older SQL Server versions, in where you have this report, this process that is critical and normally runs in certain amount of time. Let's say a report that runs for 20 minutes, and one day suddenly, out of nowhere, you get into the office in the morning, and that process has been running for 3 hours, and it's not finishing, right? And you start checking with everybody, and nobody has changed any line of code, right? And those kind of regression of something that was not modified at all, and having those problems with execution times or resources, right, is or was something quite common. The idea since SQL Server 2016 is to start putting a set of features at the top of SQL Server, which allow us to maintain a predictable performance or a constant performance, no matter if the server is under heavy load or if it is almost idle. Excuse me 1 second. Okay, sorry about that. So let's start seeing which those features may be. In SQL Server, we have all these features that we will start talking, but at the top of it, in Azure, we have another framework that helps us to do monitoring, right? That the whole Azure Monitor Metrics alert and log is something that we cannot see in our data center today with our bare metal server, right? We see with all the objects or all the components that we have in Azure SQL, right? But again, for the first time, I will emphasize on this. It's just SQL, right? So all the features that we have from, for example, in SQL Server 2005, we have them there, right? Dynamic management views and functions, right? You know that every single monitoring and troubleshooting solution in the market, free, paid, from the community, all of them are based in dynamic management views and functions, right? Those are there in every single version and edition of SQL Server. So now this concept of intelligent performance, what is all about is basically a component within our user database that will be constantly checking, right, for regressions, right, and eventually adjusting the behavior of the queries that are running, the processes that are running, to match the performance that it was using before. And this way, try to accomplish what I said earlier, right? Predictability and have constant duration in all the processes that we run, right? And with that, we're going to be focusing initially in this feature, Query Store, and then we will see what Microsoft put at the top of Query Store to improve this with the same objective, right? The one I just said, try to keep the performance constantly. And one of the things that I would like you to pay attention and see here is that all these features stay there, and the benefit is that we don't need to modify our code, right? So that's the most important part. It's not like you have to do a tuning of your queries, of your processes to be able to match or to be able to use these features. No code change, and the outcome is what we said earlier: maintain performance over time. So, well, in the dynamic management views, right, we have a common set of DMVs. There are a lot of them in where we can see health status of everything, active transaction, open transactions, indexes, missing indexes, index usage, logs, deadlocks, everything we have DMVs. DMVs are those read-only views and functions in where the engine tell us what's going on underneath. And showing in all those tables, we can come up with a bunch of useful information to do our troubleshooting. In Managed Instance and Azure SQL, because of this concept of platform as a service, there are additional DMVs specifically for each of them. Just a few of them which are more, in relationship with this concept of platform as a service. So when we go and start seeing, okay, which are the features that we're going to be focusing on, we're going to start mentioning Query Store, introducing SQL Server 2016. At the top of Query Store, automatic query tuning, right? And then few others that we will be checking one by one. Automatic query processing that then turn it into intelligent query processing, and the latest improvement in SQL Server 2019, right? So again, this concept of intelligent performance, intelligent database is what we just said, right? Have processes checking what's going on within the database and trying to find out regressions to apply a fix on the fly to accommodate the behavior to maintain a constant information. So Query Store, the very first feature, and I would say the baseline for all the other features that come at the top. This is how I like to call it, the flight recorder of our user databases, right? When we enable Query Store on our user database, this is a feature that you have to enable per user database, right? What Query Store will be doing is basically keeping track of every single query that runs on that particular user database, and will be storing the execution plan as well as the runtime statistic for every single thing that runs in our database, right? And how does it work? Well, that when you compile or you run a code for the very first time, what is going to happen is it's going to compile the plan, right? And then after compiling the plan, it will execute, right, the query itself. So in an asynchronous way, there is a store, right, within the user database that will save in a specific schema all the plans for that specific query ID, as well as all the runtime statistics, like, for example, how long it took, amount of read, writes, 10 dB allocation, etc. So with that, we have like this performance dashboard in where we can see easily, right, which are the statement or which are the options that are taking most of the time, right? We're going to see it in action in a bit. Something to consider here is that in SQL Server, the product, right, until 2019, until the one that is the current SQL Server version, this feature is disabled by default. So if you create a brand new database, create database, query store will be disabled. You have to enable it manually. On the other hand, in Azure SQL Managed Instance and Azure SQL Database, when you create a new database, this feature is enabled by default, right? Microsoft has announced that starting SQL Server 2022, when you create a new database, Query Store will be enabled by default. That's a big change as well, right? So it's quite easy to enable. It's not a big deal. We have to, we can do it. Just go in there and enable it. We will see later that there is a set of best practices to use Query Store on, for example, highly load SQL environment. Maybe a few trace flags or some specific settings on how to configure Query Store. But let's say for what we're going to be doing today, basically is just enabling it. This is there. So quite easy, right? We enable it, and then from Management Studio, we will have this set of reports in where, again, easily we can just go there and see, for example, the top resources consuming query, right? We can see then sorted by the ones that are heavier, right? And see the runtime statistics, see the plans, see how the plans were changing along the way, right? And something that I haven't mentioned yet is that, if you identify that one of those queries has changed the plan because of any reason, right? And the new plan is not as efficient as the previous one, so as a result, you are getting more duration in this process, you can manually force a specific query ID to use a specific plan from the past. This way, doesn't matter which is the current plan that the engine came up with, you're gonna be forcing the plan that you want, right? This is quite interesting because, again, it's allow you as a first step to do, the objective that I said earlier, right? To maintain the performance over time. Here, remember this was SQL Server 2016 when it was first introduced, right? So let's say that, there has to be a DBA or an operator in front of this, checking constantly to find out the regression using the Query Store report, and then forcing the plans manually, right? So if the regression happened at 3 a.m. in the morning, and someone arrived in the morning at 8 a.m. and found the regression, well, you had to do that there. So between 3 a.m. and 8 a.m. you had this regression. We will see how Microsoft added something at the top of Query Store in SQL Server 2017 to address that problem. So here there are some best practices in how to use Query Store. There is a link down there because it's quite important also to consider that if you are migrating from an earlier version of SQL Server to a newer one, you can also enable Query Store and change the compatibility level to see if you have any regressions based on the new compatibility level, right? That is also one of the common scenarios. Okay, as I was saying before, at the top of Query Store in SQL Server 2017, Microsoft added a new set of features called automatic query tuning. It runs at the top of Query Store. And what it does is that if you have Query Store enabled in your user database and you have automatic query tuning enabled, right? If internally or automatically it detects that there is a regression in any of the queries that are running on that particular user database, automatically it will set the plan to the last known good one, right? So that means for the problem that we said earlier, if the regression happened at 3 a.m. in the morning, right? If there is a regression, automatically with this feature, right, it will adjust the execution to have the previous known good plan. And with that, going back to the previous, let's say, performance metrics right away, not waiting till someone forced the plan manually. This is quite interesting, actually, right? So it's basically doing this, process of automatic plan correction, right? If something happened, right, just forcing the last known good plan. In Azure SQL Database, there is something additionally that is not available in SQL Server, which is automatic index management. That means that, if you have this feature on, you can have this process also to find out if the queries that are running on your user database may require a new index or an index that will be useful for the workload that is running. And if you decide so, it can be created automatically, right? So, when you have this feature enabled, you run your queries, your normal workload, and if it detects that an index will help to improve a specific query, it will create it right away. And eventually, if it's not useful anymore, it can be dropped on the fly, right? So quite interesting. Of course, this is something that needs to be tested quite carefully. For myself, that I'm from old school, have something creating and dropping indexes on the fly is a little bit, risky. But my experience using it is that it's really, really, really good. But for the plan correction, this is something that in Azure SQL, as I said, if you create a brand new database, this is enabled by default for the automatic plan correction. So how does it work? Well, basically, having this process, learning, which is query store, right? Storing everything related to runtime statistics and plan change, adjusting on the fly, verifying that everything that was applied or forced is good in terms of, there are no problems or further problems, and then, going back to the same process, constantly doing this, learning, adapting the behavior, verifying, and again, learning, and so on. So, for the ones that are not familiar, a plan regression is basically what we said earlier, right? You have something that is running with certain amount of minutes. It has its own execution plan in the cache, right? And for some reason, could be multiple reasons, the new plan that came up with a specific compilation is not good or is worse than the previous one, so you start suffering this regression. So what automatic plan correction does is basically, on the fly adjusting to the previous last known good plan, right? This is a view of the automatic index management in Azure SQL, right? You have, as you see, the first option, force plan, this is on, right? And then you have create index and drop index that you can enable or disable depending on your need.
Can I ask you a question about
yeah, absolutely.
The last known good plan?
Automatic query tuning, yeah.
Yeah, so when you have like a skew in your data, that's going to happen quite a lot, I guess, that a plan suddenly isn't any good anymore because you're say you have one customer who has half of the orders in the database and the rest of them just have one order each, then you would probably suffer from parameter sniffing. So and you run a batch and it's going to read, get the orders for one customer, get the orders for the next customer, and SQL Server is going to realize that I don't need a hash match here. That's not a good plan. So I'm going to pick the loop join and stick to that as the last known good plan. And then you run the query for that one customer that has half the orders, and SQL Server has decided to use a nested loop join because that's what the automatic correct plan choice correction done. What's your experience with that when you have like does it help us with parameter sniffing, or does it in fact make it worse with parameter?
Yeah. Well, what Microsoft call this is that you know, the B1, the version 1 of the feature. So they are constantly you know, trying to improve for some of those cases. With automatic query plan correction, you won't have I mean, if the plan change, what it's going to do is just to try to use the last known good one, right? There is another feature, right, which is starting in SQL Server 2017. We're going to see it in a minute, that will help you for those cases. We will reach there in a couple of minutes.
Okay.
But yes, there is something, but it's not this one.
Right.
So that part is the automatic index management, adaptive. Okay, and we just reached that point. Adaptive query processing, right? You know that historically, when the engine come up with a plan, that plan was static, right? That means the plan was compiled, generated, stored, and it's going to be used in upcoming executions until you know, there is a new plan. As you said, Magnus, you may have a store procedure which may have been executed with different parameters, and some of them returns few rows and some others returns thousands of rows. So the plan could not be the optimal one for all the cases, right? So what this feature is basically is the possibility of, you know, after compiling the plan, having it in cache, executing it, and if you know, if it detects that the plan may have some settings that may need to be adjusted, it's going to provide a feedback, right, to the engine, and for the upcoming execution, it will fix or try to adjust some of the behavior, right? Let's see some of the cases. One of the cases is adaptive join. And again, remember, this was SQL Server 2017, right? And the feature name was adaptive query processing. So for certain situations, like for example, type of joins, right, or memory grant feedback, right, we had this feature enabled, right, which allowed, you know, after executing your code and getting the stats, if it is realized that there was something that need to be adjusted for the existing plan, right, and the upcoming execution is going to be adjusted. The one I like the most, I actually are these two here: memory grant feedback and adaptive joins, right? So if there is, you know, if it's going to see it in action in a second, and you will see that how it is, right? But you know, just wanted to add something here is that in SQL Server 2019, Microsoft added an additional layer to adaptive query processing and call it intelligent query processing, right? Adding additional cases in where this feedback is entering into the scene to adjust the execution on the fly, right? So beside the memory grant feedback, right, the one that I like a lot and I use a lot actually is scalar UDF inlining. You know that historically, when you have an scalar user function, right, developers used to get quite creative, right, and put a lot of business logic within a scalar UDF, right, and then you can put that function on the select or on the predicate. And the engine was always considering that this the weight of this scalar function was 1, right? So almost no cost, but in reality, this can be a performance killer because if depending on how you use it and depending what types of operation, this was historically a big problem. I do remember when Microsoft was working on this and presenting this before SQL Server 2019 in the first community technical preview. I read an article which was saying that Microsoft is fixing a bug that has 25 years, right? Which is the problem with the scalar functions. They are doing a pretty good job in this area. Of course, there is still a lot to accomplish, right? But again, what this feature is doing is compiling the guts of the scalar UDF and embedding into the main execution plan, right? So again, now the plans are not completely static as they used to be. After executing it and after having the runtime statistic of that particular execution, it will provide feedback to adjust certain values. So the next execution is going to be better or will be more optimized. The one that is really noticeable is and easy to explain actually is the memory grant feedback, right? Consider that you execute the store procedure for the very first time, and the plan came up with a grant of, for example, 10 megabytes, right? So, okay, my plan has granted 10 megabytes. So you run it again, and the next execution, instead of using 10 megabytes, is using 1 megabyte. So you say, okay, I'm wasting 9 megabytes. Well, it's not a big deal. My server has a bunch of memory, so wasting 9 megabytes is not a big deal. But what about if that particular procedure is being executed hundreds of times per minute, right? You're going to be wasting a lot of memory, right? And on the other hand, if it was granted 10 megabytes and in reality it ended up using 20 megabytes, right? The query will run, will execute, of course, but that difference of memory, it will go to the 10 dB and it will spill to the 10 dB. And you know what happened there. The execution times go to the roof, and you're going to be hitting the 10 dB quite often, right? So, what this feature does, memory grant feedback, is that if it, required 10 megabytes and it used 1 megabyte, the very next execution, it will adjust that plan to have only 1 megabyte and don't waste, a lot of memory, right? Same for the other way. If it requires more memory, the next execution, it will allocate more memory for that plan, right? How do we enable all these features in intelligent query processing? Well, quite easy, just changing the compatibility level, right? Setting the compatibility level in 140 for our user database or 150 if it is 2019, we can easily have these features on for our user databases. An additional feature which is new in 2019 is lightweight query profiling. Imagine the situation that we discussed at the beginning. You have this report that normally runs in 20 minutes and one day is taking 3 hours and it's not finishing. what do you do? Do you know at which point of the execution it is? Till now, you did not. Now with lightweight query profiling, you have the possibility of seeing for every single query running on your SQL Server, right, the estimated query progress, right? So with that, you see if the execution is at the 10%, 50%, 90%, right? And with that, knowing that, you can take better decisions, right? If it is in 95%, maybe you wait a little bit more and it's going to be finishing. If you see that it's at the 10% or something, well, maybe it's time to kill that session and do the proper troubleshooting, right? We're going to see it in action in a minute. It's really, really useful. Something really interesting that Microsoft is doing with that is that since it's a feature that is coming by default in SQL Server 2019, right? They ported back to SQL Server 2016 Service Pack 1 and 2017, right? Not by default, right? Because, just to maintain compatibility, but using a global trade flag. If you use the trade flag 6412 in 2016 SP1 or 2017, you have this feature, lightweight query profiling enabled, right? So let's see all this in action. I have here my virtual machine, right, with crash overnight. So that is why I had to restart it. And let's see with the one that we just finished, lightweight query profiling. You have this session here, and just for you to see here, I'm connecting to a virtual machine running SQL Server 2019, and I'm also connected to an Azure SQL database, right? So I can choose either of those, and the demos will work with absolutely no problem. So here I'm connected to my virtual machine. I have this query, right? I will enable here include live query statistics, right? And I will run my query. When I do that, right, see down here that I have my estimated query progress. The plan is moving, right? Like always, but we see at which point of the execution we are at. We can see it up there at the top, or we can see it here at the bottom, right? I will cancel this one. I will run this other one. See the same concept. We see the estimated query progress, so we know at which point of the execution we are at, right? So definitely this is information that is extremely useful to take decisions, right? You can tell me, well, this is nice, but I don't run my workload in Management Studio. I have application servers, I have web servers. How do I see all this in action? Okay, so what I have here is a script which is basically running a random workload on one of the demo databases. So how do I do to check the estimated query progress for each of them? It's quite easy. You go to Activity Monitor, right, in SQL Server, something that is there since long time. It's going to take a few seconds to populate everything, but down here we have one which is active expensive query. So you see the active session. So when you check one of the session, you do right click, and now you have this option, right? Show live execution plan. So I choose this one, live execution plan. So we see it, and at the top, right, same as when we are running it from Management Studio directly, you see the estimated query progress. So it doesn't matter if it is, you know, a SQL shop, if it is something coming from a web server, a middle tier, a client, you can see the estimated query progress for anything that is running on my instance. Really, really useful, and I use it all the time, right? And it's quite lightweight, actually, right? So let me cancel this one. Now I will, I have this one to show you how Query Store works. Here, I did something in advance, basically to save some time. What I did here is I create a brand new database, right? Then the database, I create a table with 3 columns, and I create a store procedure, which is basically doing a select from that table based on an input parameter. And then I enter random data, right? So I run my script beforehand till here. So let me just go to the database. So just for you to see it, we have data on this table. I will enable Query Store here, right? So now we are starting collecting execution plan, runtime statistic, everything. So I will run my store procedure with one parameter 20 times, right? So I just run it. I go to Management Studio, I go to my database, Query Store, and then I can go to top resource consuming queries, for example. And since this is the only query running here, I should see my query ID with the plan and the runtime statistic here. So it was executed 20 times with a minimum duration, maximum duration, average, etc. Right? So next, I will create a non-cluster index on my underlying table, right? And then I will execute the procedure another 20 times, right? When I go back to Query Store here, now the same query ID one came up with a new plan, right? And as you can see, the shape of the plan is quite different now, right? And if we go to the runtime statistic, now we see that the query ID 1 with the plan ID 2 is way faster than the previous one, seeing average one versus the other. And that was just because the new plan is better. I will create an additional index. This is now a covering index. And then I will run my procedure 30 times. When I go back to Query Store, now I see that I have a third plan, right? We can switch from all of them. We see the shape of the plan here. And when we go check the runtime statistic, now we see that the plan ID 3, right, the new one, is even better, right? If eventually, the new plan come up with more, let's say, duration, we can just go here, select the plan that we want, and just hit force plan, right? This way, the upcoming execution of this store procedure will always use the plan that I'm forcing here, right? But again, I have to do it manually. On the other hand, if I enable adaptive query processing, right, I will show you my demo here. This one. Okay. What I will show you here basically is I have my store procedure, my user database created with query store, and now I'm just running some workload on my user database. If I go to performance monitor, I see, let me just clear here, that I have batch requests per second, and I have an average of 75, something like that, right? This is the batch request per second that I have right now. So let's say that I will generate a regression on my system, right? So now the batch request per second has dropped a lot, right? And this could happen in the middle of the night, and we have to again manually go to query store, fix the plan, force the plan, etc. Right? So now let's see the same behavior if we enable automatic query tuning. So I will cancel this guy. I will recreate my database, right? But the difference now is that I will run this. Alter database, set automatic tuning, force last good plan equal on. So I will run this, right? So now it is enabled. I will generate my, workload again. I'm back to a reasonable batch request per second, and I will generate the regression again. Pay attention of what's happening here. The batch request per second drop, right? But immediately, automatically is back to normal because automatically is fixing or forcing the last known good plan for the one that was bad, right? So the regression happened, but automatically it was addressed on the fly without us having to go to query store and forcing it, right? This could happen at 3 a.m. in the morning and nobody will realize, right? So this is really, really nice and really useful, actually. Then when we talk about intelligent query processing, I will show you. Remember, this is the one that is adjusting the feedback on the fly, right? The execution plans on the fly. So let me show you. This is adaptive join for the case that you mentioned before, Magnus. So I will switch the compatibility level for my database to 150. So I have my all the features on, and I will clean the procedure cache, and then I have this query to run. When I run it, I have to specify include plan. Right, it's going to execute, but now see the shape of my query plan. Now we have this new operator called adaptive join. So depending on the amount of rows that are, returning from each of the tables here, it will use one type of join or the other, right? Hash match in this case as well, right? So it will depend on the content or what is returning. So it doesn't matter if my table one day has many more rows, it will adjust the type of join, right, on the fly, and that will give us a better execution plan. For the memory grant feedback, right, here I will do the same. I will set the compatibility level back to 150. I have to specify include execution plan. Then I have my store procedure here, which is basically doing a bunch of joins based on an input parameter that we come up with, right? So I will execute this procedure for the very first time with the parameter 8, right? So when I run it, it returns nothing. I go to the execution plan, and now we see in the execution plan that we have this warning, right? When we go to the warning, we see the query memory grant detected excessive grant. So it granted a lot, and it ended up using almost nothing, right? So we are wasting memory. This plan is already on the cache. So I will run the same store procedure with a different parameter right after, right? So when I run it, this time it will return several rows, right? It's taking some amount of seconds, right? So it finished, or it's finishing, it returned 231,000 rows. When we go to the execution plan, now we see that we have these warning signs everywhere, right? Detected grant increase. So, we had the initial grant, but it ended up using way more. For the sort, since it didn't have enough memory, it has to spill to 10 dB. Same for the showing, right? So it's plenty of this warning, and notice this, it took 17 seconds, right? If I run it again, pay attention, without any code change, right? I run it again, of course it will return the same amount of row, but this time it took 1 second, right? And when I go to the execution plan, I don't see warnings anymore, right? And this is because there was this memory grant feedback, and it made the adjustment on the fly, right? So again, 0 code change, right? And we have this running. In SQL Server 2022, they keep adding different cases or more cases of this kind of feedbacks. I'm really looking forward to see it in action. For the Scalar UDF inlining, right here, I have again the database. I will set it to 150. I will create my Scalar function, which basically, depending on the customer ID, it will return if the customer is regular, gold, or platinum. Nothing too fancy, I would say. We check, and this function is what is called inlineable. This is quite important, actually. It has to be an inline Scalar using function. And now, I will change back to compatibility level 130, SQL Server 2016, and I will, run my select using the function, right? So when I go here, I get the plan. We see the shape of the plan. We have here compute the scalar, weight is 0%, so it's not paying attention to what it is in the Scalar UDF definition. Now I'm going to be switching to 150, SQL Server 2019, and I will run exactly the same select statement, right? And this time, shape of the plan is way, way different, right? We have, the definition of the scalar function embedded into the plan, so we can understand what's going on and fix it right away if we find that it's something to be fixed, right? Before, the weight of the scalar function was always very low, right? Even if the definition is quite heavy. All right, so I'm just finishing.
Can I ask you a question before you finish off?
Absolutely.
It's
Absolutely.
from Alexander Jäger. Is automatic tuning a feature of Enterprise Edition or is it Standard Edition?
You can have intelligent query processing on every edition of SQL Server. It's not the Enterprise or Standard. It's SQL Server.
That's good stuff. Good.
Yeah.
So it's still the biggest difference between Standard and Enterprise. It's the memory allocation you can give an instance, and it's the ability to do online rebuilds.
Yes, if in case of high availability, if you have an availability group, you can only have one user database in the availability group. I'm not sure if that was changed, but initially you only was able to have one database per availability group.
I think it's the same, and it has to be in synchronous mode, so you can't do asynchronous to a DR site, for example, with Standard.
And you cannot have the replica as read-only. It's just DR purpose. Yeah. Matching to how it was in database mirroring back in 2005. Memory allocation, those kind of things. But in terms of intelligent query processing, automatic query tuning, query store, is the same in Enterprise or Standard. Okay, so here I have a couple of QR code. If you want to learn more, right? Everything that is new in 2019. This one is going to take you to the official Microsoft documentation. You will see not only the features that we cover today, but all the features included in 2019. Same for Azure SQL Fundamentals, right? It will land you to the official documentation of Azure SQL Fundamentals. And with that, we finish the presentation. If there are any more questions.
And I think people, if you have questions now that the presentation is over, if feel free to unmute and ask questions if you like.
Yeah, absolutely.
From my side, I have to run off for an appointment, but feel free to, if you have questions, feel free to stay for a couple of minutes in the call. I have to drop off, unfortunately, but thank you so much for the presentation. And I do look forward to another end slide with what's new in SQL Server 2022.
I'm working on that already. I'm working on that presentation.